All right, section 10.2, ionic compounds. Here's our objectives. Be able to describe how atoms form ionic bonds, state this in terms of energy, be able to explain the octet rule, talk about lattice structures and properties of ionic compounds. Those are kind of key things out of this section. All right, first of all, ionic bonding. When you've got an atom and it has a low ionization energy, and it meets another one with a high electron affinity. In other words, we've got one who's going to get rid of an electron easily, and another one who wants to take an electron. This is a pretty common thing to happen. So in our example over here, we've got a sodium atom. Hey, it's got low ionization. It really wants to get rid of that electron. You've got chlorine atom. It really wants to fill in that spot right there. And when they meet, boom. Okay, it's magic. Usually, or in these cases, a lot of times it's just enough if they run into each other. That's enough energy to transfer that electron. Some things take a lot more. You have to put in heat or other things. But in a lot of these cases, it just takes a collision. Ions tend to stick together because of this charge. It's having a very, very powerful magnet. So you've got this positive charged ion, you've got this negatively charged ion, and that pulls them together very, very tight. This is an extremely strong bond. This is known as an electrostatic attraction. Okay, this is, the electrostatic attraction between those two charged ions is known as an ionic bond. And this is one of the most stable, strong bonds that we know of. The octet rule is kind of an expression that says that when the group A elements are trying to form ions, they always try to get to 8. They always try to get to 8. Or my version of this is 8 is great. Always trying to get to 8, either by losing an electron and going down a level, so if you've got sodium, which has 1 valence electrons, it'll try to get rid of that one, and then its next level is full. Or if you've got chlorine, which has 7 valence electrons, and it's trying to steal this electron to get 8. Either way, they're trying to get to 8. 8's kind of the magic number, and it's a very stable configuration. Remember, at this point, the reason 8 is the number is because we have S's and P's full. S's take 2, P's take 6. Once that is full, that's a very stable configuration. Let's talk about some properties. When these ionic compounds form these compounds, they organize themselves into different patterns, and they can be different. Like, for instance, this example right up here would be like sodium chloride salt, and you'll notice that it's, there's a purple, then a green, then a purple, then a green, every other one. And that's a pretty common, that's one common arrangement for an atom that loses one electron and another atom that gains an electron. It kind of can put them together like that pretty easily. Okay, the one down below is a little bit different, but it's another arrangement of atoms that you have, and there's just like, this is a little harder to see, but there's like 2 kind of in the middle surrounded by like 6 on top and 6 down below and so on. These are known as lattice structures. So the way these ions arrange themselves, that's known as its lattice structure. And we shouldn't refer to ionic compounds as molecules, because they're not. Which one of these is NaCl? That one, or this one, or this one? How do I know which one of those goes with that sodium ion? So we really shouldn't call them molecules. Usually they call them either lattice structures or crystals, and that's what they're referred to. Some typical properties of ionic compounds: they have very high melting points, very high boiling points. In fact, for like salt, I think salt's boiling or melting point is like over 800 degrees Celsius. So, I mean, we don't even have anything in the lab that can get that hot to melt salt. They also tend to be brittle. They break easily. Take a look at this picture with a hammer, And notice that, on the left here, where these are normal, you've got a chlorine, then you've got a sodium, and a chlorine, and a sodium, and so on. And there's always, a negative by the positive. But if you hit them and you actually move these things, now all of a sudden you've got a negative by a negative, negative by a negative, and that tends to repel, forces them apart. And this is why they shatter, because when you hit them and you move them just enough, and you get the similar charges together, they're going to repel each other and they're going to break, they're going to shatter. And that's a lot different than like a metal. You can pound a metal and it doesn't shatter. You can shape it and do all that. But you take a crystal and you hit it with a hammer and it just shatters. Also, they tend to dissolve easily in water. These have a charge, and water tends to have a charge on it too. It's known as a polar molecule, so usually most of these ionic compounds dissolve pretty readily in water. They also will conduct electricity if they are melted, molten, liquids, if they're molten, or if they're a solution. So if you put salt in water and dissolve it, it's a very good conductor of electricity because those ions, remember electricity is negative electrons moving through, those ions will transfer those electrons very easily. The other really interesting thing is that the chemical and physical properties of the ionic compound have no resemblance to what they started with. If you take, for instance, sodium and chlorine, okay, sodium is a metal that if you expose it to air, it's going to react. If you put water on it, it'll start to burn. It's very, very reactive metal. Chlorine is a poisonous gas, okay, very reactive. Both of these things, if you were to eat either one of those, sodium metal or chlorine gas, breathe in chlorine gas, it would kill you. Either one of those would be bad. But if you put them together, you get table salt, which we put on our food. Compounds are very, very different than the original atom. In fact, it's the ions. The ions are very, very different. So just the sodium ion is extremely different than a sodium atom. Chloride ion, very different from a chlorine atom. And there's the end. Thank you.